Alright, so now we're going to be going over the Unit 3 Manufacturing Systems final review. And of course there's the vocabulary, which we're going to be using for this section. And then there's the quizzes that you need to complete. After that, the multiple choice. And this is where we're going to start in the video. So let's go ahead and go through the question and read and highlight the vocabulary. Which of the following would most likely result if human workers were replaced by robots in manufacturing? And so these were our vocabulary words, and we have assembly. We talked about assembling things. Some of the vocabulary words are also in the answers. We have an increase in labor costs. We talked about labor costs. Decrease in productivity, and we talked a little bit about product reliability. So read it again. Which of the following would most likely result if human workers were replaced by robots in a manufacturing assembly line? This is the question. So what would happen if human workers were replaced by robots, if we replaced humans with robots in manufacturing? An increase in labor costs. Well, labor is the cost of paying human workers, so no. A decrease in productivity means we would get less work done. No. We did not talk too much about investments, but actually robots would cost you a little bit more in terms of investment, so increase in initial investment. That's not true. Increase in product reliability. Yeah, so robots are more precise and accurate and reliable, so that would be D. During which of the following manufacturing stages of manufacturing a wooden rocking chair are the pieces of the chair fastened together? Now, putting pieces together, we discussed assembling, we talked about conditioning, finishing, and forming. So all of those we studied. You just have to know what it means when we are putting pieces together. And what step is that? Here's the question. Which of these means putting pieces together in manufacturing? And it's assembling. In manufacturing, it is important to perform routine maintenance to maintain quality and safety. We talked about quality and safety in manufacturing. Which maintenance procedure is performed for the sole purpose of ensuring that measurement, we talk about measurements, are measuring accurately. So we talked about all those things. In manufacturing, it is important to perform routine maintenance to maintain quality. So this is talking about quality and safety in manufacturing. Which maintenance procedure is performed for the sole purpose of ensuring measurement instruments are measured accurate? So we're talking about safety and manufacturing and measurement. So if you look at these, which one of these words means measurement, and that's calibration? None of these mean measurement. Okay, so, and the question here was here, so focus on that. That's the question, right? And the question really focuses on measurement to measuring, and that's about calibration. We can go a little bit closer. Oh, we're still recording. Good. Okay, which of the following is the best example of a finishing? Okay, hold on one second. Okay. Which of the following is the best example of a finishing process in manufacturing? So, best example of a finishing process. Here's the question. What vocabulary is in the question that we want to focus on? It's finishing and manufacturing. And finishing, again, is making something beautiful. If we go back to the definitions and we look at finishing, it's painting, it's making something look attractive, look good. Here we're talking about painting surfaces, right? So painting is a finishing step. Remote controlled robotic arms, so we did talk about robots, are used to clean up contaminated areas. Which of the following best describes why robots, rather than humans, are used for this task? And here is the question. Why robots and not humans? Why robots and not humans? Again, this OSHA keeps coming up, but we didn't talk about OSHA. I think I've seen that in 3 or 4 questions before this unit. So robots rather than humans, and we're talking about clean up of contaminated areas. To minimize expense, cost of safety equipment, no. To avoid human exposure to hazardous, dangerous waste, right? So why use robots and not humans? To clean up contaminated areas. And this is talking about the weather, to limit human exposure to weather. No, that's because contaminated areas are dangerous, they're hazardous. That's why we use robots. This is a tricky question. It gives you a lot of information on tolerances. This is how close to a measurement you can get when you use a certain machine. And an engineer uses this when they want, hey, good morning. What's that? The copier's saying there's not enough toner? Yeah. Sad day. For now, yeah. So this, oh, thanks for the eraser and rubber band. Do I need to be flexible? Yep, remember to be flexible. Okay, teachers are flexible. Okay, so which is most likely reason an engineer uses this chart? These are tolerances for some machining process. Tough question. We talked about engineers. We talked about processes. Let's focus this a little bit better. And engineer and design. So to improve the ability of the machining process to make the part to exact dimensions, not really. To adjust the machining process to minimum tolerances, no, this is not adjusting. Each process is telling you which process has different tolerances. To determine which process can make the part within a required tolerance, yeah, maybe. And to make sure that the part is larger than the maximum dimension for the machining process, no. The answer is C. Which of the following qualities of material, we talked about materials, is most important when you want to consider before the material is sheared? So before you can cut something, you need to, with some shears or scissors, you need to consider how thick the object is. Because if it's too thick, then some shears won't work. You couldn't cut a table or a really thick piece of metal with common shears, but if you use a thicker set of shears specifically designed for cutting metal, you can actually end up cutting sheet metal with something similar to a scissor, and that's thickness. In the illustration below, a thick sheet of metal is being passed through 2 rollers to produce a thin sheet. So here we're going from thick to thin. Thick to thin. There's not a lot of vocabulary in this question other than what type of manufacturing process. So know your different processes. We did study casting, forming, molding, separating, and very similar to this question here, you just need to know the definition of each. And here they're changing the shape. They're going from thick to thin. That is changing the shape. That is not casting or molding. They're not separating anything. Separating means to cut. It's not that. It's got to be forming.